The European Union has just embarked on a truly ambitious legislative journey with its new AI Act. It's a foundational attempt to write the rulebook for a technology that is evolving at a remarkable pace. So the central question is, how do you regulate something as powerful and frankly as unpredictable as general-purpose AI? In this explainer, we're going to examine the blueprint for this new legal architecture. To understand this complex regulation, we'll navigate through its 5 core components. We'll begin by looking at how responsibility is assigned. Then, we'll explore the challenge of creating standards for a constantly changing technology. After that, we'll be introduced to the new governing bodies for AI, see how the law is designed to evolve, and finally, we'll synthesize our findings. So, let's start with the first principle, responsibility. In the intricate ecosystem of AI, a model might be developed by one entity, but then deployed in numerous applications by others. This raises a critical question. Who is ultimately accountable? The Act's approach is to meticulously map the entire AI value chain to provide an answer. Now, before we proceed, it's essential we're all clear on the terminology. The Act centers on what it calls general-purpose AI, and the crucial part of this definition is that it's not about what the AI is intended to do, but about what it is capable of doing, its inherent powerful generality. This single concept forms the bedrock of the entire regulatory structure. And here we arrive at the Act's most significant innovation. It establishes a clear legal distinction between the AI model and the AI system. You can think of it like this. The model is the engine, a powerful but raw component. The system, on the other hand, is the finished car, where that engine is integrated for a specific purpose. Regulating the engine and the car as separate entities fundamentally changes the landscape of legal responsibility. This distinction creates a tiered framework of obligations, with the requirements becoming more stringent as the potential for risk increases. At the base level, all GPAI models must adhere to transparency rules. For the most powerful, or systemic models, those with the potential for widespread societal impact, a robust risk management framework is required. And at the highest tier, when any model is integrated into a high-risk system, say for medical diagnostics, the final product must comply with the EU's most rigorous safety standards. So what is the practical outcome of this structure? The Act effectively shifts the primary legal burden downstream. The entity that develops the foundational model has a duty to provide clear and comprehensive information, but it is the entity that integrates that model into a high-risk product, the system integrator, that assumes the full legal responsibility for its safety and conformity. This brings us to a rather fundamental challenge. If you've established a framework for responsibility, how do you then write the specific rules and testing protocols for a technology that is in a constant state of evolution? This is truly the central dilemma of AI governance. Traditional regulatory approaches depend on fixed, predictable specifications. But the very nature of advanced AI is its capacity to adapt and develop emergent capabilities, which can render static rules obsolete almost as soon as they are written. The Act's solution to this problem is quite elegant. It recognizes that attempting to define a good AI model is a futile exercise, so instead, it focuses on regulating the process. It mandates a rigorous, repeatable, and responsible process for developing, testing, and monitoring these models. The focus shifts from the final product to the quality of the journey that created it. This process-oriented approach utilizes several key mechanisms. It begins with flexible codes of practice, which are developed in collaboration with industry to serve as initial guidelines. For the most powerful systemic models, however, the requirements are more demanding. They mandate formal model evaluations and adversarial testing, which is essentially the practice of systematically trying to find the model's flaws and unexpected behaviors before they can cause harm. The long-term objective is to formalize these best practices into harmonized technical standards. A new legal framework naturally requires new institutions to oversee its implementation and enforcement. In this third section, we'll examine the new supervisory architecture established by the Act across the European Union. This new regulatory landscape is governed by 3 key entities. At the European level, the new European AI Office will serve as the primary regulator for GPA models. To ensure consistent application of the rules, the European AI Board will coordinate among the member states. And finally, at the national level, each country's market surveillance authority will be responsible for overseeing the final AI systems placed on the market within their own jurisdictions. This design creates a very logical 2-level enforcement structure. Since a GPAI model is a digital product without physical borders, it is most effectively supervised by a single central body, the European AI Office. This approach avoids the inefficiency of having 27 different national authorities attempting to regulate the same model. However, when that model is integrated into a final system, for example, a diagnostic tool in a hospital or a financial instrument in a bank, it becomes a product within a specific national market. In these cases, supervision logically falls to the national authorities of that country, who possess the relevant local expertise. To ensure these regulations are taken seriously, the Act is equipped with substantial financial penalties. These fines are tiered according to the severity of the violation, but for the most serious breaches, they can reach as high as 7% of a company's global annual turnover. This sends an unambiguous signal that compliance is not discretionary. This leads us to one of the most critical considerations. How can a piece of legislation in this area avoid becoming obsolete shortly after its enactment? In a field characterized by such rapid advancement, how do you design a future-proof regulation? One of the key triggers for the Act's most stringent rules is a technical metric, the amount of computational power used to train a model measured in flops, or floating point operations per second. The initial threshold is set at an immense level. The challenge, however, is that any fixed number is vulnerable to being quickly outdated by technological progress. The Act's first defense against obsolescence is a built-in, continuous review process. It establishes a multi-speed cycle. The lists of high-risk and prohibited applications are reviewed annually. The entire regulation is evaluated every 4 years, and the AI office itself will undergo a targeted review. The objective is to treat the law as a dynamic, evolving instrument. Yet the Act's most potent tool for staying current is a legal instrument known as delegated acts. This grants the European Commission the authority to quickly amend certain technical, non-essential elements of the law, such as the flops threshold, without needing to go through the full, lengthy legislative process. This mechanism is the key to the Act's intended agility. This situation effectively creates what has been described as a governance race. The long-term success of the AI Act will depend on whether its adaptive mechanisms can keep pace with, or even anticipate, the rapid trajectory of technological development. So let's synthesize what we have discussed. The EU AI Act is more than just a new set of rules. It represents a novel architecture for regulating a powerful and transformative technology. Let's recap the core design principles. First, the Act's architecture legally separates the AI model from the final AI system. Second, it shifts the primary legal liability downstream to the system integrator. Third, it establishes a dual-level governance structure with central oversight for models and national oversight for systems. And fourth, it is designed to be adaptive. Ultimately, its success will likely depend on the institutional agility of the new European AI office. And this leaves us with the final critical question. The legal structure has been built, but the race has only just begun. The ultimate test will be whether the human institutions charged with governing this law can adapt as quickly as the artificial intelligence they seek to guide.